So we've got a couple of news items for you today, and the first thing is from Equipmake. It's a UK-based kind of components manufacturer for electric vehicles, and they've got the Ampere 220. It's an e-axle system. So that's a high-power, high-performance electric vehicle axle system, which has 3D printed electric motors on it. Now, we've heard some other companies work at 3D printed electric motors. This could be a huge application for 3D printing. Additive Drives is doing this. Other companies are doing this. Other companies or research institutes are instituting it. And we could just get better power density. We could get more efficient, lighter, more highly functioning electric motors. And of course, electric motors are expected to grow very, very quickly. So this is so the 3D printing in this case is used for the general housing to consolidate parts, to reduce weight, and to make the overall engine, the motor part, more efficient. In addition, they've got power electronics, a silicon carbide inverter, and this, or similar to this engine, was used with the Ariel hypercar. And it's got a peak power of 220 kilowatt, maximum motor speed of 30,000 RPM, and it just weighs under 20 kilograms. Now, normally you would put one of these on a wheel or one of these on a couple of wheels. But generally this is for kind of like a newer, this is for newer, higher speed or higher performance vehicles. Power density is 11 kilowatt per kilogram. And yeah, again, this 3D printing is being used here to consolidate the overall components, to reduce weight, and also for better thermal management. So incorporating all these things mean that this thing just becomes more efficient and more cost effective with 3D printing. I think this could be a giant application we need to spend a lot more attention on. The next news is from Cincinnati, and Cincinnati is now the home of Voxel, it's a startup which is closed a series seed round for 1.7 million, mainly by Cincy Tech. They're basically doing AI plus multi-physics modeling to generate designs and design optimization to improve iterations, specifically for functionally graded metamateirals for high performance designs. So this is one of these things where it's like, oh, that's going to be really useful in the future when we're looking at gradient parts. To give a higher performance is going to be useful to create metamaterials that can do all sorts of things, all sorts of actuators, complex assemblies, complex parts that can function way different than we can imagine now. Rather than making a whole series of parts in a really complicated assembly, you could make a metamaterial that could really deal with all that complexity on a material level. Now, so I love this. I love that they're working on this. But this is one of these markets where eventually it'll be breakthrough. So how is the company going to be finding its initial clients? How is the company going to be finding it? Because we all know that expressing these metamaterials and getting them printed is very, very difficult, and also trying to figure out how they work. So on the one hand, it's an amazing tool for a world that hasn't happened yet, but is it going to be the right tool to spit out these parts and make them more prevalent, right? Can they turn this into files that can work on 3D printers? On what part of 3D printers can they work? Right? That's the kind of thing. So it's one of these things where, maybe they're a little bit too early or to find a market, maybe too early to find really significant customers, or there might be right in time and might usher this market in. Anyway, that's generally very exciting. Now, this next thing is something we've talked about before, but I wanted to point out again because I missed the application. So this is the XXL 3D Druk, which is run by Laser Center Hanover and a bunch of other partners to create a really large-scale wire arc additive manufacturing system. Now, wire arc, again, it capable of spitting out a lot of material very quickly. In this case, it's over 3 kilos an hour. The problem with it, how coherently does it spit it out? It's always been, I call it FARNet shape as a kind of joke. See, hey, it's great for spitting out a lot of material, but at the same time, it's maybe not so great at doing that in a very, very coherent way and getting materials without a lot of machining time. Because often then, it's either, well, if you can use it very roughly, fine, and otherwise if you have to post-machine it to get it to have a mating surface or to get it to be a particular shape, it's going to take you a lot of time. So having said that, if someone makes WAAM work, it's going to work really well because it's super cheap and super duper fast. In this case, they're making components up to 3 tons from the build volumes of 3 to 4.5 meters. And what I'm really interested in, I missed this the first time, and I thought, well, maybe you did too, and this could be really exciting, is for this company called Reintjes. This is the first installation of this printer, and they're making marine gearboxes. Now, these are immense things that are basically the gearboxes of giant ships. Now, what they're trying to do is save money on the one hand on just the supply chain portion, making less molds, less mold steps, so that could do a quicker time to market, and maybe save money on that. But they also hope to make lighter weight components, using less material, which will make it cheaper for them, but also making it lighter weight. Now, in this case, a gearbox for a ship is actually a component that the ship has to carry around, right? So reducing weight there is especially advantageous, and especially also since then it can move more efficiently, perhaps. Or it can be installed more efficiently, or just generally it would just cost less to make. So there's multiple innovations here possible. Of course, shipping is responsible for a disproportionate amount of emissions. These emissions are also disproportionately dirty because they are comprised of like the dirtiest oils and materials that we have. So any kind of improvement there could be really very highly impactful. So what they hope to do is to reduce the weight of this gearbox by 20%. Now, these things are immense. Some of these components are several tons, and some of the 3D printed components so far have been several tons in weight. So 20% reduction, which is pretty easy to achieve with additive generally, could have a huge impact on the performance and the price of the gearbox, but also have a huge impact on shipping in the world and shipping in general. This is something I kind of missed the importance of this. I kind of missed this application. I thought it was really, really fantastic, and I wanted to share it with you just in case you, like I, missed it. My name is Unpeeled. This is another version of 3D printing news Unpeeled, and I hope you found this valuable, and I hope you have a very good day.